Welcome back, everybody. We hope you got a little bit of a break during our intermission. We're going to move on now to the graduate student portion of our day, and I am going to introduce all three students that will be speaking, and then we'll let them come up and take their turns. Our first student will be Jaime Garzon. He is an agronomy PhD student who is being advised by Dr. Joe Vendermeedy, and Jaime is originally from Colombia. And so also second, we'll have Caetano Sales. He's an agronomy master's student, excuse me, who is being advised by Dr. Brent Sellers. And Caetano is originally from California. Then we have Leandro Vieira-Filho. I practiced, I really did. I used Google and I practiced. He's a soil and water sciences PhD student who is being advised by Dr. Maria Silveira. Leandro is originally from Brazil. So we'll start with Jaime. And if I think Andrea's ready, so we'll go from there.
Okay, hello everyone. First of all, I want to thank you all for being here, assisting this short presentation named Ecosystem Services of Overseeding Achinomene into Bahia grass pastures in Florida. As we know, the legumes are plants that we usually can mix with grasses, and those will have an effect in the productivity of those pastures. This is normally related to the forage yield and nutritive value. But nowadays, we can also measure other ecosystem services that those pastures can give to us, as happened with the nitrogen fixation or the impact of nitrous oxide emissions. Talking about legumes, this is the Achinomene americana. This is a summer annual legume that we use here at South Florida. It's well adapted to our conditions, especially our soils, our weather. It is normally used together with Bahia grass in the grasslands, and is native from the United States. Due to that, the part of the objectives of my dissertation was to measure how could be the effect of this legume when we introduce it with Bahia grass into the pasture, related to those ecosystem services that I mentioned before, and how could be the nitrogen fertilization affect the responses as well. After 2 years of experimentation, we concluded that actually for the herbage accumulation, the inclusion of Achinomene into the pasture didn't affect the biomass amount into the pasture. At contrary, that happened with the nitrogen fertilization. But on the other side, here we have the average. Well, in the second graph, we have an average that we do in those 2 years was 4 clippings for harvest. And we could see that after the second harvest, those plots with Achinomene deposited more crude protein than those with only Bahia grass. And that effect increased month after month. This was caused, between others, by the nitrogen fixation capacity of the legume. And in average, in those 2 years, we could measure that the Achinomene by itself fixed approximately 230 pounds of nitrogen per year per acre, and was more directed in those last clippings. And finally, we have the nitrous oxide emissions. In this case, we could see as well the average in those 2 years. We could see that at the beginning of the measuring time, we have one peak. It was higher but shorter than the second one. And that happened by the nitrogen fertilization. But also we have the second peak. This was longer and was not expected for us, and matches at the moment when the legume is having the better performance. But at the end, the treatments that we analyzed didn't affect the accumulated nitrous oxide emissions, mainly because of the variation between samplings. To conclude, the Achinomene mixture increased crude protein concentration without difference in herbage accumulation, and also the Achinomene effectively fixed atmospheric nitrogen and impacted nitrous oxide loss. Thank you very much.
Good morning, everyone. Thank you, Laura, for that introduction. My name is Caetano. I'm a master's student here under the supervision of Dr. Brent Sellers. And thank you, everybody, for joining us today at the center, and thank you for joining us through Zoom. In the last couple of years, Corteva Agriscience has discovered a new synthetic auxin molecule named by fluoroperoxyfen benzyl. And they developed a premix of that with aminopyrrolin and launched it into the market as Duracore that has been recently approved for pastures and rangeland. And our goal here was to look at the use and the efficiency of Duracore on weed control and forage tolerance in Florida grazing lands. So what puts Duracore in the spotlight is its low use rate, being environmentally friendly, and also that it does not have any restrictions, any restricted use, and does not contain 2,4-D or dicamba, which are compounds known to have some problems with volatility and are components of other pasture herbicides such as Grazon Next and Weedmaster. So the objectives of our study was to evaluate weed response to Duracore on its own and along with other tank mix partners for optimum weed control, and look at established forage tolerance as well as during establishment. For this quick presentation, I'm going to show some data on dog fennel, which is an important issue to cattle producers, as it's one of the most problematic broadleaf weeds in Florida pastures. On this graph on the right, our y-axis is our control percentage, and our x-axis has our treatments. They are Duracore on its own at 16 fluid ounces per acre, and Duracore with tank mix partners, such as Pasture Guard at 8 ounces an acre, Weedmaster and 2,4-D both at 48 ounces an acre. We performed visual injury evaluations on dog fennel plants at 30, 60, and 120 days after treatment. So at our 30-day evaluation, initially we can see that Duracore on its own does not provide any good levels of control to dog fennel plants. However, when added to tank mix partners, we see that it increases substantially that levels of control. I forgot to mention here that we applied our treatments with MSO, with methylated seed oil, or non-ionic surfactant as adjuvants, and compared all our treatments to our standard of Grazon Next at 24 ounces an acre and Pasture Guard at 8 ounces an acre. So continuing, we did see that adding a tank mix partner increased the levels of control. And that was also seen visually here with Duracore on its own and Duracore with Weedmaster with either adjuvant. Another thing that I wanted to point out here is that initially we can see a statistical difference between treatments with NIS and treatments with NSO. However, if we jump into our 60-day evaluation, that difference is no more. And what we hoped to see was a response from dog fennel plants to Duracore on its own does not happen. It does not reach 50%, the mark of 50% of control. But when added to tank mix partners, it reaches at least 65% of control, going up to the heights of over 90% of control, and all comparable to our standard. That trend continues throughout the season until our 120-day evaluation, where all our tank mix partners are similar to our standard of Grazon Next and Pasture Guard. So our take-home message here is that initially Duracore will require additional tank mix partners for optimum dog fennel control. And we've seen similar results in other studies looking at dog fennel's response to Grazon Next that also shown that Grazon Next will require tank mix partners for dog fennel control. Thank you.
Good morning, everyone. My name is Leandro Vieira-Filho. I am a third-year Ph.D. student advised by Dr. Maria Silveira. Today, I'm going to talk about one of our projects, the evaluation of agronomic and environmental impacts of new Florida DEP biosolids rule. This new Florida biosolids rule was made due to public concern on nutrient loss, which causes the eutrophication of water bodies. But what changes with this new Florida DEP biosolids rule? Well, sites with seasonal high water table is smaller than 6 inches are no longer suitable to biosolids application. from now on, it's mandatory to enroll on best management practices. Biosolids application will have to be applied on a phosphorus-based rates instead of nitrogen-based rates. And last, water quality water quality monitoring may be required depending on the amount of biosolids being applied. So these new changes may cause some unintended problems, as for example, it will be applied more in organic fertilizer. For example, the areas that are no longer suitable to biosolids application are very likely to receive some amount of inorganic fertilizer, which is already proven to cause to be more harmful to water quality than biosolids. And last, farmers and ranchers may be discouraged to apply biosolids due to the increase in the operational costs. So here we have some preliminary data on the new biosolids rule. We did an experiment on we applied biosolids in an organic fertilizer, and our control, we didn't apply anything on a established Bahia grass pasture. And there was no statistical difference between biosolids application and inorganic fertilizer application, but of course, biosolids application was better than our control. So, but when we compare this data with the same experiment being conducted under the old biosolids rule, we see a huge decrease in forage production when we reduced the amount of biosolids being applied. This reduction was about 40%. Here is some preliminary data on phosphorus leached in milligrams. These are water quality data. So we didn't have any statistical difference between control biosolids and inorganic fertilizer application. The statistical difference only happened over time, over the sampling events, as we can see on this graph. So our conclusions here are that the new Florida DEP biosolids rule will cause a reduction in Bahia grass herbage accumulation when using biosolids as the only nutrient source. And lastly, that regardless the rate or source, no environment impact was observed. That was all for today. Thank you very much.